Good evening to you viewers and subscribers, and welcome to another video. My name is Belly One Engineering. I hope that you're keeping yourself safe and all is good and well with all of my viewers and my prospective subscribers. Now in today's video, I'm going to be continuing my concrete proportion mix series. I am going to be delving into an alternative way how you can come up with your mix proportion for your concrete. I know that I've said to you in my last video that I'm going to be talking about the slump test, the temperature test, and the air test, but I will push that for next week, and I'm just going to be continuing my calculation on concrete mix proportion. So without further ado, I'm going to be getting right into the tutorial. So stay tuned. Thanks. Coming from my last video, I have demonstrated to you how to work out the volume of concrete for this pad footing detail, and the volume of that concrete works out to be 1 meter cube from a dimension of 1 meter high by 1 meter in width by 1 meter in length. And the quantity of cement, which we have worked out in our previous video, works out to be 0.14 meter cube, which ended up work out to be 5 bags of cement. Now, if you haven't catch on to my calculation from my last video, those of you who have watched my last video, how to calculate this volume of 0.14 meter cube into 5 bags, I'm going to be doing a short demonstration of that. And if you're watching this video for the first time and you have not seen the previous video, I'm going to give you a small demonstration of that. So therefore the weight of cement, or the density of cement, is 1,440 kilograms per meter cube, and we times that by 0.14 meter cube, the volume for the cement, and the result of that is 201.6 kilograms, and we rounded up this 201.6 to 202 kilograms. Now, a bag of cement weighs 94 pounds from what I can remember, and the equivalent of that 94 pounds is 42 kilograms. So to arrive at the number of bags of cement, it is 202 kilograms divided by 42 kilograms, and the ratio of that works out to be 4.8 bags. And we rounded up this 4.8 to become 5 bags of cement. So that's how we know that 0.14 meter cube is equivalent to 5 bags of cement. Now, to continue with the mixed proportion, the quantity of sand works out to be 0.29 meter cube, or 0.37 cubic yard, and the quantity of stones works out to be 0.57 meter cube, or 0.74 cubic yard. As all these calculations was done from my previous video, so in the case you're watching the video for the first time and you're wondering where these values comes from, they comes from my last video. The weight of water works out to be 84 kilograms, or 185 pounds. Now, if you're not comfortable with working with the weight of water in pounds, and in the event that you do not have a scale on your site to weigh the water, you can convert this 185 pounds to liters, or you can convert that 185 pounds to gallon. Now, now 1 pound is equivalent to 0.45 liters. So you times that 185 pounds by 0.45, and the result of that is 83.25 liters. Now, to convert this 185 pounds to gallons, it is 1 pounds, which equal to 0.12 gallons. So therefore you times this 185 pounds by 0.12, and the result of that is 22.2 gallons. So therefore, basically, the weight of your water, which is 185 pounds, is essentially 83.25 liters, or 22.2 gallons. So that is more a better way or to quantify the weight of water. You can just get a gallon bottle on site, and you measure it in a container, and you know what's gallon full that container, and you can use that container to weigh your water to pour your concrete. Now, to mix your concrete. So there's an alternate method how to calculate the volume of sand and the volume of stone, which I consider is much more easier than the way that we have done it last week. So the one in the mixed proportion represents your cement, and it governs the mixed proportion of your concrete. So if you want to find out the volume of sand, all you have to do is to multiply the volume of your cement by 2, and you obtain the value for your sand, the volume for your sand, or the quantity for your sand. You do the same thing for the stones. You multiply the volume of cement by 4, and you obtain the quantity for your volume of stones. So you can look at it now. So for sand, it is 2 times 0.14 meter cube, and the result of that is 0.28 meter cube for the sand. And the stones, it is 4 times 0.14 meter cube, and that works out to be 0.56 meter cube. So if you look at the previous quantity for your sand that we calculated last week, it was 0.29 meter cube, and now the volume in this alternate method works out to be 0.28 meter cube. So you can see the comparison that there's not much of a difference between the two values. As a matter of fact, the difference is very negligible. And if you look at the volume of your stone for our previous calculation last week, it was 0.57 meter cube. And if you look at the calculation for your stones, in this instance, it is 0.56. Again, not much of a difference, negligible difference. So now I'm going to demonstrate to you how you can quantify your aggregate on site by eliminating the use of this 0.29 and the 0.37. I know that is going to be complicated for some of us to quantify using decimals and points. So I'm going to show you how you can convert this in a easier way to come up with a better method to quantify your aggregates for your concrete mix. The volume of sand is 0.29 meter cube, or 0.37 cubic yard, and the volume of stones is 0.57 meter cube, or 0.74 cubic yard. So I know, as I mentioned before, is that it's going to be difficult to quantify these measurements on site. So what you can do is convert these measurements to cubic feet. So you can convert the 0.29 meter cube to cubic feet by multiplying this 0.29 times 0.29 meter cube by 35.29. Remember now it is 1 meter cube, which is equivalent to 35.29 cubic feet, and this is derived from 3.28 cube, and you multiply that 3 times, right? Because 1 meter is equivalent to 3.28 feet. The same thing for your cubic yard. 1 cubic yard is equivalent to 3 feet cube, right? And this is going to be 3 times 3 times 3, which is 27. So you can convert this 0.29 by multiplying by 35.29, and the value of that is 10.23 cubic feet. And similarly, you can multiply the 0.27 cubic yard by 27, and the result of that is 9.99 feet cube, and you round that up to 10 cubic feet. Now to measure 10 cubic feet on site, right, I'm going to show you a way how that can be done. Now, if you're going to use a wheelbarrow to proportion your mix, the ideal thing for you to do is to find the cross-sectional area of the wheelbarrow and times it by the weight. But the shape of the wheelbarrow is going to be very, very difficult to come up with that cross-sectional area. So the other alternative is to make a measuring box. A measuring box consisting of 1 feet in width and 1 feet in length and 1 feet in height, which works out to be 1 feet cube. So what you will do, you will fill this measuring box with sand, and you count how much of this measuring box will be needed to fill this barrel. So you fill it with sand, and you use to fill the barrel, and you count how much times that it will take this measuring box to fill that barrel. So let's say, for argument's sake, in this instance, it takes 10 of these measuring box to fill this barrel. Then you would know that this barrel measures 10 cubic feet. So in this instance, to come up with your volume of stone, which is 0.29 meter cube or 0.37 meter cube, it works out to be 10 cubic feet, which will work out to be 1 barrel. Now, I'm not saying in reality that this measuring box, which is consisting of 1 cubic feet, fills a barrel 10 times, right? I'm not saying that. I'm not saying that in this instance, based on my calculation, just to show you a better way, you can just use your measuring box and fill the barrel, and then you will know how much your barrel measures. So that's a way how you can simplify the measuring on your site using a wheelbarrow, instead of talking about using decimals on meter cube and cubic yard. You can just convert them to cubic feet. Another important information that I want to pass on to you, that previously I mentioned to you that it is better to factor your mix by a certain factor. So in this instance, you are using 124, as we are using consistently. You can either times this ratio by whatever you want. Whether you want to times it by 1, 2, 3, 4, 5, right? To come up with the respective quantity for each of these items: the cement, the fine aggregate, and the coarse aggregate, right? So if you're the person, if you are the person responsible for running your site, all I'm saying that do not come up with a arbitrary number of sand and tell your labor to just run on that amount of sand without doing the necessary factoring of your ratio. So let's say for argument's sake, you alerted your labor on site to run on 7 barrels of sand without doing without factoring the mix. So 7 barrels of sand, right? And remember now, the 2 in the mixed proportion is for your sand. So if you run on 7 barrels of sand, you now would have to find out the multiplying factor of your ratio, right? So you will have to divide this 7 by 2, and the result of that is 3.5. So you would have to times this ratio by 3.5 to get a consistent mixed proportion, right? So 3.5 times 1 is 3.5, right? And 3.5 times 2 is 7, which works out to be the 7 barrel that you have instructed your laborer to run on. And 3.5 times 4, that works out to be 14. So your mixed proportion is going to be 3.5 cement, 3.5 barrels of cement, 7 barrels of sand, and 14 barrels of stone. But the difficulty I'm having with this mixed proportion is that you do not want to work with 0.5 or decimal, because no one is going to have the time to measure out half of a barrel of cement, right? And more often than not, that is not going to do. You're going to only run on, you're going to quantify 3 barrels of cement, which you're going to rob your mix half a barrel of cement. So that is why I'm saying do not arbitrarily run on any number, because when you run on arbitrarily any number, if you have not factored your mix, you have to come up with the multiplying factor to make sure that your 124 is consistent with a particular factor, right? So that is it for this video, and I want to just alert you that the reason why I've taken you through this exercise is to just make your material for your mix optimum in terms of cost. And when you can work out your material for your concrete mix, it saves you time and money. So in the event that you're going to the hardware or whatever or wherever you buy your material, you do not buy excess of material and you do not buy less. Because if you buy excess, you're going to throw away material that is not going to be used in your concrete, and that's money. And if you get less material to do your concrete mix, you have to make several trips back to the hardware to or wherever you buy your aggregate to get the additional amount to come up with your mix, and that is going to cost money for transportation. And in another instance, it's going to rob you of productivity on your site. So that is it again for this video. If you like the video, please share the video. Please remember to comment. If you have questions, let me know in the comment section, and we'll be very happy to answer your question. And do remember, if you're watching my channel for the first time, to subscribe. Thank you, and that's it for this video.